Alright, hello everybody, hello from your favorite artist electronist, Mr. Q12, with a new project. This is about a new chip that I acquired. It is called ATtiny44A. This is the folder. This is one pinout, but I like this one better because I'm having this ICSP diagram in it. That's why I like it. ICSP, it means in-circuit serial programmer. These brown markers, this 10, 11, 12, and 13, if you look here on this legend, it says where to link those pins directly on this chip. And as you can see here in my setup, so those green wires are the links from those pins. Using Arduino Uno, in my case, revision 3, R3, as ICSP programmer for ATtiny44. In my case, I have ATtiny44, not AT4, but showing here together. So this is the chip that I'm having. This is the datasheet for this chip that I look inside it, but not that much, because I got some very good help from Arduino forums. I worked 2 days with one guy, and he helped me a ton. So many thanks to this guy. Let's see. Here is the actual chip with all its pins, 1 to 14. This is more summarized, but here is more detailed. So it's the same as in the datasheet, but this is better because you have a ton of details here. And also this ICSP programmer. This is very beneficial. So this datasheet is about 3 chips: ATtiny24, ATtiny44, which I have, and this 84. One very important thing is that this chip is quite old and is not that good as memory size and also pin numbers. A lot of aspects is compared with ATmega328 that I programmed in my last big project, and that microcontroller is a bit more modern compared with this ATtiny44. But what I like about this chip is size and the shape. Is having all these 14 pins is looking very much like a logic chip from the 40 series, or like 4017 or whatever, or 74, like those logic chips that I'm usually used to work with, and it's quite nice to work with them. So this is very familiar from the appearance point of view. So that's why I choose it, that's why I like it, and that's why I wanted it. I choose it for a very specific project that I came across, and let me search it. When I was making the project with the rotary encoder, I came across this board with a rotary encoder with this transparent plastic knob that is lighting up, is having internally some LEDs, but it costs $25 only for this little component, if you want, this little board, prototype board. This is the actual name of it, RGB rotary encoder breakout, and it's $25 for only this one. And I was curious, why the hell is that expensive? And the page on it, it also showed this backside. I could decipher what are those numbers, and you can barely understand what it is because it's very pixelated. But then I started to Google it. Pretty much I put my mind to it, and I come across this ATtiny44 chip that he is using, and it's very similar. Even if you don't really understand what the hell is going on there, what those numbers are, I come across as this one being used most probably here in this board. So this is actually a very genius idea, using this microcontroller for that rotary encoder to receive signal and to transmit decoded signal. So it's very interesting idea, and I like it. And partially I took this project under my divine wings, and I will repeat this board. I will make it by myself. It's a very good and interesting project to decode a rotary encoder to have its own board. That was one reason for why I choose this particular microcontroller, because of this board. So this is the history of it, why I choose it. But it's not only because of that. Like I said, I like its shape and I like its form, how it's like 14 pins side by side, not square, not weird, not too long. It's quite a good package. I really like it. So it's only aesthetics. I choose it because aesthetics only. I actually made a list. You know, I want to keep this movie as short as possible. we can discuss these problems. There are a lot of problems. I actually made 2 lists here, an Atmel with all the tinies, and this is a tiny list with ATtiny numbers, but the list I looked on Wikipedia is gigantic, because they are going they started probably in the 80s or the 90s. I'm not sure when they started, but they made thousands of models and numbers, and this is just a fraction. It's a little blimp how many chips they have from Atmel. So this is the big corporation Atmel, and this is just a model, this tiny model, but they have even other brands, other models, Mega. They have I don't have paper and I don't have enough files. I don't know where to obtain the entirety of all the models they have, but they have with thousands. So this is just a little fart of data what I'm having here. It's just nothing what I'm having here compared with what really it is there. This is a list of Atmega series. I try to understand the corporation logic. I try to understand what they did and what they make, and I wanted to see more chips from them. That's the reason I made these 2 files that you are seeing here. And then I made this file, Atmega and PIC microcontrollers comparison list. This is the data that I collected for a couple of them to compare what I have to what is out there. So pretty much what I'm having here is what is out there. And this is what I have, a tiny part of microprocessors. But actually it's not what I have. I have a bit more than that. I have a couple more than 3. It's not only 3, but I only made the list for these 3. I wanted to present to you that I made my homework. Before I decided, I said, yes, I will take this ATtiny44 and that's it. These are the 3 most important descriptions for absolutely every microcontroller is out there. The flash program memory that is having, the memory that you are putting your program into it, data memory, SRAM, this is how fast is moving its bits, how fast is syncing, an EEPROM bytes, but this EEPROM is very important to know and to have it. And I didn't have it for a lot of PIC microcontrollers, and I looked on more than this PIC12F508 and this 16F84. I looked on a couple of more of them, and they all have, the majority have, of PIC microcontrollers, they have this 64 EEPROM in them. It's like a standard size. It's very shitty, very, very low EEPROM size. PIC microcontrollers, and they don't actually mention it, or I failed to see it, to think about it, what it means. Even if I've seen it specified in their datasheet, but I swear to God, I don't remember it mentioned in their datasheets. I have no idea if they even mentioned this particular detail, this EEPROM size. They are mentioning the flash program, yes, the data memory they are mentioning, but this EEPROM part is not mentioning. That's why you are seeing it here with a different color, because I didn't I wasn't very aware of it, to be sincere. So only when I got into Atmega chips, when they are putting it on the table with the face up, all this data and everything, this is it. This is what we have. But these motherfuckers, they subversively don't want to tell you everything. So that's the problem with PIC microcontrollers. They are very good microcontrollers, but on the other hand, they are very, very shitty to work with, very shitty. That's why it's very, very nice to work with Atmega chips. I'm not paid by anybody. This is my honest opinion, my personal experience with them. Believe me or not, it's your business, but this is my experience. I'm trashing the PIC microcontrollers. I'm praising the Atmega chips because they are way, way more easier to program and to understand them and to work with them and to obtain data a bit more elegant, way more elegant than with this. I spent a ton of time with them and I didn't do anything good and fast with any of my PIC microcontrollers. I don't have a good history with them. I couldn't make too many projects with them. That's the point. Okay, that's it for this part. And I made a test program like you are seeing it here. Test code for ATtiny44 is not really that big of a deal. It's flipping 2 LEDs back and forth. Unfortunately, I didn't make a schematic, but I have some pictures of the circuit that you are seeing here. Before I'm starting to program anything, I should probably show that. Yeah, I took some pictures while I was building it. So this is the ATtiny44 chip, and I really like its shape. And these are SMD LEDs, 2 LEDs and 1 resistor. And you can see it noted here what kind of LEDs I used. I used orange LEDs, and this is 1.3 kilo resistor. And later I will add here a capacitor on positive and negative of the chip. This is the layout. This is the drawing for all the components, and I believe the chip is already glued. Yes, it is glued, and I put here, I'm showing is a piece of cardboard between this chip and this surface. So the legs of the chip are not on the cardboard here. They are lifted a tiny little bit from the cardboard, the thickness of that cardboard that is in between them. Why I did that? Because I have experience with SMD chips. When I'm mounting them like this, when they are touching the cardboard gets burned. So to avoid burning, it's good to have it lifted in the air a tiny little bit. So this is a trick. It comes with experience. Here, as you can see, I'm adding the metallic pads, at least on this side. This wiring with the crayon, they become very, very useful when I actually linked the wires, I mounted the wires. Very, very helpful to have this wiring already established. And here I put these pads and also these 3 components here, but no wiring. So right now all the pads and all the components are assembled. And here I'm starting the wiring process. I'm putting everything on the table. I'm sorting the wires there. I put my finger there to compare with my finger the size of the wires and to the board itself. I linked only the first wire, as you can see here, the first this positive 5 volts wire to the pin. And the next one, I actually put all the wires. I linked all the wires, including these ones here, very short wires to these 2 pins. The circuit that I followed, actually, this was the circuit that I followed, exactly this one. So what I did, I linked from these pins to those external pads. These 6 As you can see, 1, 2, 3, 4, 5, 6 pads. I linked them here externally. That's the way I'm doing things. And here are the LEDs. And I also specified here that I put on this pin and on this pin those two LEDs. But I didn't really get into the detail. I kind of get lazy here on drawing the proper way of drawing the LEDs with the resistor on the ground. But you can understand what is going on here. Those two LEDs. This green marker that you are seeing on all the SMD components is usually is the negative pin of the component, and they are separated. There is a distance between them. So this pad is linked to this pin and this pad to that pin. You can see it in code actually. It's LED on pin 0 on pin 2, but I didn't knew this detail until later. This was a big mistake. I will talk about it later. So here is another picture. I took a picture from the top, and it's looking pretty nice. A very good resolution. You can see a lot of details, even some tiny drops of resin. So this is how I hook it up on my breadboard. So from here I linked these wires. So this is positive, that is negative, and I link it to this little DuPont pins, and I inserted them. And here I have 4 pins. You cannot see it because of the low resolution. And here I linked this wire, you can barely see it, negative to there, and these 4 lines into there, to their respective pins, 10, 11, 12, and 13. These are the connections here. I also actually mention it here if you are paying attention. You see 10, 11, 12, and 13. This is 0 volts, that's plus 5 volts. So these are the pins of the Arduino that these pads are going into. Like I said already, I basically copied this into this. That's all I did. And then I power it from outside, from a very small power supply with positive 5 volts, negative rail, and I linked the negative rail with a wire on the negative rail of the Arduino board. And this is another angle, another shot, and I forget about it when I designed it. So my friend insisted to add a capacitor, which is looking like a resistor. Many people didn't see this type of capacitor. Hey, that 100 nano capacitor, I've never seen something like it. And my response, sure, you've seen it. Mine are scrapped capacitor from miscellaneous boards. It is also an old type with old markings as they used to do it in the past 80s or 90s probably. The equivalent, or better say the makeup ones you encounter today are these ones. And here this is pretty much the same thing as those. So this was my response to him about this very strange looking capacitor that is looking very much like a resistor with these bands, but I can assure you it is a capacitor. It's an old marking type of capacitor. Okay, so and also scrapped. Yes, and in this picture, after I mounted that capacitor there, as you can see, I don't have that external power supply anymore. So this is the final circuit here when I'm collecting the 5 volts from the Arduino board through this wire, this orange wire, and the negative rail of this breadboard and my circuit as well is through this more thicker, stronger wire that is making a better contact than the wire that I had before. Yeah, this was a dinky wire, and the pins, I wasn't very sure if they are catching very well. So I changed this. I changed that wire with a thicker and better, doesn't matter the thickness, but the pin that is inside is making a better contact than the other flimsy one. So that's what I did there. This is the final picture. So to clarify, these 2 LEDs that I put here, I put them to test this program. But I didn't make this program when I put those LEDs. These LEDs, I put them here, and then after I put them there, I made the program. And I made a terrible mistake, or actually a rookie mistake, in the very beginning when I made the program. I put here 11 and 13, which are the number of the pins of the chip. In the very end of the discussion on Arduino forums, after I figured out how to make it work, then I realized that this is actually a digital pin. I was looking here on PKInt, and what I was having there, I was having 11 and 13, and this is 11 here, and 13, it doesn't exist. And I was actually getting one single LED lighting up very, very slowly. It was doing this loop that you are seeing here, but very, very, very slowly. I was having originally 1000 delay there. So that's how I realized these gray markers here are the digital pins that you have to actually put them in code, and not the actual chip pins. This is pin 0, which is 13. My LED is on that pin as well, and on 11 is actually pin 2, digital pin 2. I had a little bit of problem originally, but then I figured it out. Enough about this part. Let's actually start showing the program itself, how I make it work. So my friend here suggested me this core. Now I'm getting a bit more expert in cores in Arduino. So this is the core. When you get to tools, here on the board, you see a board, and these are all cores. Arduino Avir boards. These 2 others are cores. This ATtiny4 and MiniCore here. MiniCore is for Atmega 328 that I already programmed it successfully. And this is the new ATtiny4. Exactly this first one, ATtiny44 chip that I'm having right now, with no bootloader. There is another option, ATtiny44 and 84, with optional bootloader. I had to read this guy page. Is this here on GitHub? This ATtiny4, I go to manage library, I search it there, I find it, and also look carefully for the name, for the author. So ATtiny4 by Spence Conde, this guy. This helped me quite fast to know that I'm getting the right core. And then, do you see this page? It's starting from here, and when I'm doing this, it's having a ton of text and also some images. But I actually read everything here. That's why it took me 2 days to make it work. And I couldn't find an installation. I searched, I read everything. What the fuck? How do I install this ATtiny4? I was having problem with installation. Usually the general data, you find it here in this main page. Here in the description, you get the general data, this guy product. And then my friend here on Arduino forums, he told me, everything is there, you can find it. And he linked the installation page to me. And then I got, what? How this guy is find that page? And when I look here more attention, it says here installation. It's a very, very short page. And then the programming from all this page that I already, this readme, long ass readme page that is having here. So this is how I find. So this is the page. Actually, it's telling you how to connect everything here. It is actually mentioned here in this Arduino ICSP programmer. Here is the same data that you are seeing here. So remember, is pin 10, 11, 12, and 13 is in order. So pin 10, 11, 12, and 13. And then ground and 5 volts. And that's it. In total are 6 pins. So it's in accordance with this little diagram what I'm having here. So this helped me a little bit to decide that my picture is the correct thing. So let's actually start and program the thing. The very first thing you have to do is go to File, go to Examples, then Arduino ISP. ISP, it means in serial programmer. We are transforming Arduino, that Arduino board, into a programmer for other chips. That's what this means. And then we are choosing only this option. And it will open this new window. And here on the top is mentioning Arduino ESP program. This also is having the name on this tab, and also here on this window, Arduino ESP. So you have 3 locations where to verify that you have the right program, pretty much. Let's program our Arduino and make it a programmer, transform it as a programmer for our chip, our new ATtiny chip. I did a mistake by leaving all this stuff because I was playing with it and I forget about it. And I was burning my Arduino Uno with all these settings that I'm having here, which is very incorrect. And this, half a day until I discovered this little mistake I did here. And my friend on Arduino forums, he didn't catch it either. Although I provided to him a lot of pictures, he didn't catch it either. What you have to do, and I actually had to go back and look on how I programmed my Atmega 338, and that helped me very much. So this is how you program it. You have to select whatever you have here on the board. So this board is referring to that board, on our programming board. We must have Arduino Avre boards, Arduino Uno selected. When we are selecting that, it's changing all of this into Arduino Uno, as you can see. And here COM5, and here programmer Avre ESP. I don't know what Avre means, but ESP, it means in serial programmer. These are all the settings, these 1, 2, 3 settings that we have to use. So now we are uploading it, just simply upload it. And you will see, after it's finishing here, that LED is blinking a little bit. You see? And that's it. Ta-da! And here we are having a little confirmation that is done uploading, and we are not getting any errors. When I was not using this proper board here, the proper options, when I was having all that ATTinyCore settings here, I was getting a ton of errors. So this is very important to do it right. And that's it. We are done with this program. We can close it and get back to my test program. Yeah, you see, this is the pictures that I posted, and I made it clear. I found the problem. This is how you upload correctly that Arduino ISP sketch, Arduino ESP file. You choose programmer and you choose Avre ESP. And also Arduino Uno here, board. This is very interesting here. Many settings in the tools menu are actually fuses. I didn't know that. Here in the tools menu, all these settings that we are seeing here are actually the fuses, at least in the core, for this course, are the fuses for the chip, or the chips that you are using. Very, very interesting details. I was not aware. I'm learning on the way. So right now, let's set up the proper way to program this chip. We have already installed this ATtiny4. We are choosing this no bootloader here. And actually, to be very sure we are using the correct settings, here is a screenshot of my earlier tests that I did. Tools, ATtiny44 is what I'm looking for. No bootloader. This to be selected, ATtiny44A is what I'm having here. Clock source is 8 MHz internal. Pin mapping is this first one clockwise. LTO, I have no idea what it means. To remain as enabled. Tiny NeoPixel port, I have no idea what it means. Milliseconds, I actually disable it. Here in my program, when I was testing other programs, I was actually having a milliseconds function. If you don't use it, disable it. If you don't use these functions, because as you can see here, they are eating some memory, I believe. So this is very interesting to not load the chip with specific functions to save some space from it. Yeah, from retained option here. Baud level, it is set as disabled. Port com is COM5. In my case, and here the programmer actually is Arduino as ESP. Arduino as ESP. Let's go back and check it. Yes, it is this option here. This is it. Now we are uploading the program. I'm pressing upload, and we should not see any kind of errors. We are seeing blinking. And voila. And the LEDs. And also here is the confirmation, done uploading, and absolutely no errors here in this field. And our LEDs are blinking right now. Fantastic, fantastic, excellent, excellent. So that. Like I mentioned already, they are orange LEDs, if you remember. All right, so this is it. This is the test program that what I did here. This is the setup, how you set up this particular chip, ATtiny44A chip in my case, and what core to load, and what settings you have to do to make it work. All right, so the clock speed problem, what I originally set it as 8 megahertz internal, which is this option here, is moving very slowly. I can blip in the same time as this is blipping. Blip, blop, blip, blop, blip, blop, and it's very, very slow. I can leave this text here for you to read what I discussed in my sketch program. I specified originally delay 1000, which it means 1 second, equal with 1 second exactly. But right now it is about 1 second. But look what the delay I'm using. I'm using this 100 milliseconds, a tenth of a second. And this is not a correct timing, what I'm having here with how it is moving in reality. This was a problem. And today I look and tested more carefully. Clock source is the cause. So for some reason, this 8 megahertz internal is not actually driving the code correctly. The speed is not correct when you choose this 8 megahertz for this particular chip. At least this is my experience, what I'm having here. All these are external, and I'm hunting for internal. Like this one, 8 megahertz internal. I'm hunting to see if there are other internal options. And there is this 1 megahertz internal option, and this another option 4 megahertz internal. So in total, 3 options. This 1 megahertz, 4 megahertz, and 8 megahertz. All these 3 options are internal. So right now I choose this 4 megahertz internal, and now it will work. And it is working with 1 megahertz. The speed is correct. So now when I'm uploading the program, the LEDs will move very fast. Yeah, see? As fast as I'm specifying here in this function, delay 100. If I'm making this 1 second, and if I'm uploading it, it is actually moving by the second right now. So this is functioning correctly. Now, if I'm changing just for you to see back to instead of 4 megahertz to 8 megahertz as it was, and when I'm uploading it, you will see it will take a lot of time. So now it's remaining on one LED open, but it will change, but very now it changed after a very long time. I believe it's 10 times, like 10 seconds right now. I believe this is a bug. I discover a bug. It must be a bug in this guy coding. So either if I'm choosing 1 megahertz or 4 megahertz, it is working correctly. So it is already set on 4 megahertz. And now if I'm uploading it, it will move by the second exactly as I specifying there. So problem corrected. I was thinking actually maybe my chip doesn't have 8 megahertz internal clock speed. So I actually opened up its datasheet, as you can see here in the title, and calibrated internal RC oscillator. By default, the internal RC oscillator provides an approximate 8 megahertz clock, but it should work with this 8 megahertz. This option that I thought maybe my chip is not having it, but it appears to be quite a bug from this core. Probably it will be corrected in the future after I will mention to this guy this little detail. A lot of problems I had, but I managed to make it work. This is it. This is all that I wanted to show. This project is, again, another success for the glorious Q12 here. And thank you very much for watching. Thank you very much for listening to everything I had to say here. And I'm starting to become an expert on cores and tool settings here, all these tool settings. I'm starting to learn them and to get very familiar with changing between them. And yeah, it's a good thing to learn stuff and to test stuff. And it's good. It's good for the future. Okay, thank you very much for listening. Thank you very much for staying with your favorite artist electronics, Mr. Q12. Thank you very much for watching my video, for understanding all the problems, and to see that I'm making mistakes. But even if I'm making mistakes, I'm not giving up easily. So you should not give up easily either. And also seek help, because alone you cannot do shit in this world. There are way more smarter people than you and me, and we should talk and find help, and if possible, even receive it. So many thanks, my friend here, Let's see. Okay, this is it. Thank you very much, and bye-bye from your favorite artist, Mr. Q12. Arrivederci. Sayonara. Aus Wiedersehen. Salutare la toată lumea. Salutare și pe mai târziu și fugiți tare. Ok, pa. Arrivederci. Ciao. Bye-bye.